This is the formula which summarized Einstein's theory of relativity, a theory which gained him a Nobel Prize. Einstein took mass, or the atomic weight of a substance, and the speed of light, which is constant, and expressed their relation to energy in a simple equation.
The search for a theory of quantum gravity is one of the most active areas of research in quantum physics. This is because the current theories of quantum mechanics and gravity are incompatible, and finding a way to reconcile them would be a major breakthrough in our understanding of the universe. Gravity is a fundamental force that is responsible for the motion of objects and the curvature of space-time. It is described by the theory of general relativity, which was developed by Albert Einstein in the early 20th century. General relativity is a classical theory that works well at large scales, but breaks down at small scales, such as at the level of atoms and particles. Quantum mechanics, on the other hand, is a theory that describes the behavior of very small objects, such as atoms and photons. It is based on the principles of wave-particle duality and uncertainty. It is able to make accurate predictions about the behavior of quantum objects. However, quantum mechanics is incompatible with general relativity, and there is no known theory that can reconcile the two. The search for a theory of quantum gravity is a major area of research in physics, and it is one of the biggest unsolved problems in science. There are several different approaches to this problem, including string theory or loop quantum gravity, but none of these theories have been able to reconcile quantum mechanics and general relativity. If a theory of quantum gravity is ever developed, it would have important implications for our understanding of the universe. It would allow us to understand how gravity works at the smallest scales, and it could lead to new discoveries about the fundamental nature of reality. In summary, the search for a theory of quantum gravity is one of the most active areas of research in quantum physics. It is an attempt to reconcile the theories of quantum mechanics and general relativity, and it is one of the biggest unsolved problems in science.